From slidenerd, this is Vivs. What's up, guys? Today we are gonna move to level 2 programs. We're gonna have prime numbers between 1 and 100 and see how we get that. So you have here's the output 2, 3, 5, 7, blah 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 up to 100. Whatever numbers are prime, we're gonna print them. So the first question I will ask you is this: what is a prime number? And if you don't know maths, just like me, then you're probably stuck at this question. So I'm gonna tell you what exactly it is. Take a number like 7, divide it by everything from 1 to 7 and observe carefully. You will see that 7 by 1 is 7, there is no decimal point. 7 by 7 is 1, again there is no decimal point. Otherwise, in every answer you will see decimals, right? That means 7 is perfectly divisible only by two numbers, that is 1 and 7 itself. So when you have a number like this, it's called a prime number. But on the other hand, if you take a number like 6, here is what you will observe. 6 by 1 is 6, 6 by 2 is 3, blah blah blah. In short, in the case of 6, there are 4 numbers which do not have a decimal point, right? That means it's not a prime number because there are 2 numbers in addition to 1, and in addition to 6, that is 2 and 3, which are also divisible by 6. That is why 6 is not a prime number. So how do we do this programmatically? Well, the thing is this, the logic is very simple. If you can tell that there is only 2 integers after dividing, then it's a prime number, right? But in this case, if you see 1, 2, 3, 4 integers, so if you say that there are 4 integers after dividing, then that is not a prime number. So that's what exactly we are going to do by using a function called ceil, math.ceil. Now as the name says, ceil means the ceiling. That is, if you give it 4.0, on the left side, on the right side it gives you 4. If you give it 4.1, it's very greedy. It says, no, I want 5. If you give it 4.5, it's again very greedy. It says, no, I want 5. If you give it 4.9, it'll say, no, I want 5. So here, in this case, what are we going to do? We have to do one thing, right? We have to count how many numbers do not have a decimal point, right? If there are exactly 2 numbers that do not have a decimal point, like 7, that is 7 by 1 equals to 7, this 7, 7 by 7 equals to 1, this 1, these are the 2 numbers which don't have a decimal point. So if we are able to count this exactly, then we can say that it's a prime number. Otherwise, well, it's not a prime number, it's a composite number. So what I'm gonna do is very simple. Now once you have divided all this stuff, forget whatever there on the left side. Take only the answers. You see the answers over here: 7, 3.5, 2.33, 1.75, blah blah blah. For each answer, calculate its ceil. That is this. That is, take the answer 7 on the left side. On the right side, you will get 7. Take the answer 3.5 on the left, you will get 4. 2.33 on the left, you will get 3. 1.75 on the left, you will get 2. So every number will be rounded off, right? Every number is going to be rounded off. But 7 is going to be 7 and 1 is going to be 1 even after rounding off. So in short, after rounding off, you will know that exactly 2 times the number has remained the same even after rounding off. So that's exactly the logic. If you round off the number, that answer after rounding off and the answer before rounding off, if they are the same exactly 2 times, it's a prime number. So check this out. This is exactly the steps. Divide the number from 1 to the number itself. Like if you take 7, divide 1 to 7. Check if the result, that is this 7, 3.5, 2.33, 1.75 equals to the ceiling of the result. So here take a ceiling of 7, which is 7. Take a ceiling of 3.5, which is 4, right? Now if they are both equal, increase the counter by 1. You may manage something called a counter. Every time you find, okay man, 7 is equals to ceil of 7. Yes man, increase the count by 1. Now 3.5 not equals 4, fine. 2.33 not equals 3, fine. At the end, when you come here, it will be like this: 1, which is your result, will be equals to 1, which is the ceil of your result. So you will say, okay man, increase the count. So in short, here you will increase the count once, and here you will increase the count another time. So if the count is exactly 2, that means it's a prime number. Otherwise, no. Now if you take the case of 6, work it out. Let's see what happens. Here 6 is the answer, right? It's the result. The ceiling of 6 is gonna be 6. 3 is the result. The ceiling of 3 is gonna be 3. 2 is the result. Ceiling of 2 is 2, right? The count is 1, 2, 3, because every time the result is the ceiling of result, we increase the count by 1, right? Again, in the last step, 6 by 6 is gonna be 1, which is equals to the ceiling of the result 1. So in this case, the count is gonna be 4. If the count is 2, it's a prime number, right? Otherwise, it's not a prime number. So I hope you guys understood this. I'm gonna go into NetBeans and I'm gonna show you how this works. Once we can tell if one number is prime, we can definitely tell if 100 numbers are prime or not. So I'll catch you guys up on NetBeans. Let's go and get this baby up and running.